Hey everybody, this is Larry. This is day 10 of the Leetcode December daily challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem, Valid Mountain Away. So I am looking at this problem live and I am solving this live. So my explanation is a little bit slow. Feel free to watch this on 2x or something like that or fast forward. Yeah, anyway. Valid mountain away. Given an array of integers away, or return true if it's a mountain away. Okay, so it's a mountain away if, okay, so it's strictly increasing. It's a mountain away if it is strictly increasing and then decreasing, right? Okay. So, yeah, so I think there are a couple of ways you can do this. I don't think this is anything difficult. It is an implementation problem in terms of algorithm. I don't think there's anything conceptually difficult. You just have to figure out how to do it. And for me, when I first see this problem, that's what I recognize, and that's what I'm trying to think about. It's just about the implementation detail. And the implementation detail is, well, how can I write this as quickly as possible without in a clean way, right? And I has to be in the middle. Okay, just so that, I think that's a caveat where or maybe an edge case where if it's just strictly decreasing the entire time, then that's not good enough either. Okay, because I actually got bitten by a variation of this on one of the Q4s lately on a contest. But yeah, so how do you solve this, right? Well, the way that I'm going to go about it is just that a valid mountain away does only have one peak. So as long as we find the number of peaks and that number of peaks is 1 exactly, I think we should be good. Yeah, and I think that's what I'm going to do. So let's label that. Let's do peaks. And the reason why you can show that is that because if there are multiple peaks, then and you could kind of visualize it. Maybe I would draw it on a whiteboard or something, but I don't really, I don't have the equipment. But basically the idea is that if you have 2 peaks, then it looks like this, right? And if you have 2 peaks, then, well, and that means that there's a bottom, and then, that means that is a mountain range. And in the other case, if it has 0 peaks, then that means that it's just strictly decreasing or increasing. So that means that it's also now a mountain, right? Or it's a mountain away. But yeah, and you can also extend obviously beyond 2 to 3 just by like induction and stuff like that. So that's the way that I'm going to implement this. And once you kind of figuring out that logic and it's kind of cute, then you should be able to do this in a straightforward way. So n is equal to the length of the array. For index in range sub, we want to start from counting from n, and then we want to actually go to n minus 1 inclusive. So is it inclusive? Actually, yeah, we want it to be inclusive to the n minus 1, so we'll keep it at n. And then now we go if r sub index is greater than, has to be strictly greater than index minus 1, and r sub index is strictly greater than index plus 1. We don't have to check for bounds here because we know that it's going to be within bounds. Actually, it's n minus 1 because we don't want to get the last element. That's right. Then we do peaks plus minus 1. And at the very end, we just have to return with peaks is equal to 1 exactly. And I think that should be good enough. And that's what I mean by implementation, is that once you kind of thought through the problem out a little bit more, then you're able to write like a quick for loop. And if you look at people who solve, like if you look at a contest and people solve in like, a minute, this is how people do it, right? Because if you write a for loop and it's easy to, or it's harder to make mistakes, and it's easy to write, easy to read, easy to debug, then that's how you're able to solve and submit problems under a minute. Right now I'm going to, run the test. It looks okay. I think it has to be at least 3 elements, so that's good. So let's do the, strictly increasing part and the strictly decreasing part, and yeah, so it looks good. Let's give it a submit. Hopefully that's good. Ooh, huh. Oh, I see. That is an edge case that I did not consider, so that's a little bit unfortunate. And that is that that a peak is actually on the edge, on the beginning or the end, and there are a couple of ways to handle it. I just didn't consider this case, so that was whoops. And the way to consider it is just padding negative infinity on both sides, so that yeah, it either goes increasingly or decreasing from depending on which direction you go to. But that sucks because that was a silly mistake, to be honest. So yeah, so infinity is equal to yeah. I did forget to consider the boundaries. That's all. Oh, and in this case, wait. Maybe that's not a good enough way to solve it. So I am trying to solve in a clean way, and obviously I ate a little bit on that one, saying that this is clean. So okay. So I think the only thing that we have to do is just check that the last. I mean, I think the more direct way is just that we have to check that if index with 0 is less than array of 1, because if this is not the case, then that's going to be false. And also if the last element is greater than or less than the second to last element, then we turn false. But we might actually, because of this, we have to make sure that this is true. For some reason, I thought that was the constraint, but actually the constraint is just one item, right? So, so yeah. So, but obviously, if it's less than 2 items, this should crash. Yep, it should give you a wrong answer. So let's add a additional check here. But I would say though, this is not what I like to do, because you become, you know, case analysis. You have to keep on thinking about whether these things are true. So yeah. Oh, whoops! I meant the inverse of this. That's just a typo, because if your first element is bigger than your second element, that means that at best it's going to be decreasing away. And so, and the same thing for the last 2 elements is that if the last element is greater than the second to last element, then at best is it increasing away, and there's no way to get a mountain peak. So yeah, let's run the code again, and hopefully it looks a little bit better. It does. Let's give it a submit. Hopefully that takes care of it. Ooh, wow. Oh yeah, okay. See, that's why I don't like. That's why I try to think about a way to kind of unify these. But the short reason is because after I change the way, if they're equal, they're flat. It's still not the case. Silly mistakes. So I have to be a little bit better about it. Need to sleep more. That's my excuse. I'm sticking there. Wow. Okay. So this is. I think this is true, but it's not. Oh. Oh, I don't handle the duplicates, do I? Or like numbers that are equal. Because even though there's only one mountain peak, there are a lot of wow. So I guess what I said is all wrong. And thanks for watching. But I've been trying to rush through this a lot. But apparently there's way more test cases. I think this is the part where I go, okay, I tried to be a little bit too clever. Let's step back and let's just rewrite this the dumb way. I try to be too smart, and this is what happens, right? But I mean, I know that I could have adjusted some more, but I think at some point, and this happens both on an interview and also a contest, no matter how easy you think it is, the short answer is if you're wrong, it doesn't matter how easy it is. And sometimes you get into these cases, and you kind of saw me there, where you patch existing things, hoping that, you know, you catch all the cases. And I think this is actually the last one, but sometimes it's worthwhile to just restart from scratch, reset yourself. The assumptions that you were making were not correct, so let's kind of make other assumptions, and or like scale back your assumptions and think about what went wrong, and then just, you know, start from scratch and keep it simple, keep it stupid. That's and I think I tried to be too clever there, and that's usually what happens. But yeah, so let's start with increasing. Oops, is you go to for. So we want just an implementation. We want it to be we want it to be true. We want it to be increasing and then decreasing, right? So now now we look at two adjacent elements. So let's go left, right is in zip of array, and this is how I write for every pair of adjacent elements, and this is in Python. So it's relatively performant, but definitely you could also obviously just walk through it one by one, but this makes it easier for me. But yeah, if left is you go to right, then we return false. If left is greater than right and increasing, then this is good, right? So we don't have to care. If left is equal to greater than right, if it is not increasing, meaning if it's decreasing, then we return false because we want it to be decreasing. Otherwise, we just keep going. If left is less than right, I think I mixed this up. This is wait. All right, let me step back and say it in English. It makes it easier. Okay, so if left is less than right, that means that we still have the increasing part going on. So if not increasing, then we return false, right? If left is greater than right, then if it is increasing, then we want to return false. Otherwise, actually, if it's increasing, then we're going to set it to not increasing because it's okay. That means that now you're on the dip part, right? The falling part, it is now decreasing. So increasing is equal to false. Yeah. Yeah, and that's pretty much it, really. Because I'm just thinking through the states of, okay, if it's already falling, then it's good, right? So these are what I call and what is known as loop invariants, and these are things that don't change when things change, and I think that's what I'm trying to think through here. And then at the very end, we return true. We could get to the very end. The only case that is false is if they're equal, or if you're trying to go increase while you already used increased once. This is another way of counting the peak, but now we take care of the last two elements as well. Let's see how that goes. Oh yeah, and it has to be at least 3 elements. So I guess that's a thing, because otherwise it's not going to be true. Well, actually, also at the end, we have to make sure that increasing is false, right? Because that means that we have to at least have a decreasing part, and we also have to have at least one increasing part as well. So we should check for that as well. So yeah, so in the beginning we have to have an increasing part. So let's do that. A is less than, or it's greater than or equal to a sub 1, then we return false. Also, if length of array is greater or less than 2, we also return false. Okay, so I think those are the cases, and it kind of makes it easier. I don't know, maybe I spent a lot of time on this problem. Hopefully you get to see my thought process and kind of debugging and what happens when things go wrong and how to take care of it. I know that by itself, if you're struggling with this problem, maybe it's a little bit weird, but I would also say that this is a pretty okay problem. So you should be, like, if you're watching it, then maybe, you're looking for something else, and hopefully that's the case. But yeah, so what's the complexity of this? Well, we look at each element one, so it's going to be O of n. We don't use any extra space really other than this increasing variable, so it's going to be O of 1. Yeah, let me know what you think about this. I know that I didn't do a great job solving the problem, but hopefully the explanation was okay, and hopefully the thought process, makes sense. I think debugging and figuring out when to give up, when to start, or like rework the problem, is very important, because it is the thing that I consider most related to real life programming is debugging, right? Debugging and fixing it and questioning your assumptions and thinking things through. Yeah, cool. Let me know what you think, and I will see y'all tomorrow. Bye bye.